Hi there, my name is Mr. Chick and I'm here to tell you about electrical circuits. This video has been designed to help students understand how electrical circuits work. First off, we need to start off with electrons. The electrons are like magnetic objects attracted to a magnet. The north side of one magnet is attracted to the south side of another. The north side of one magnet is repelled by the north side of another. Electrons are negatively charged particles. They are attracted to the positive side of the battery when the circuit is complete. This is because there is a potential difference in the circuit. The electrons flow in conductors because they are free to move. Current and charge. The current can be thought of like water in a river. The electrons can be thought of like water droplets. The river current is how many water droplets pass every second. In an electrical circuit, the current is how much charge passes every second. The electrical charge is carried by the electrons. It can therefore be thought of as how many electrons pass. The current is the amount of charge carried by electrons that pass every second. Voltage. The voltage can be thought of as how steep a river is. A lake does not flow because it is flat. Water flows in a waterfall because it is very steep. A river will flow because it goes from higher ground to lower ground. The reason this happens is because there is a gravitational potential difference. In an electrical circuit, there is an electrical potential difference. This means the electrons have the potential to do work or transfer energy. Each volt is how much energy can be transferred per unit charge. Resistance. The resistance can be thought of as how much obstruction there is in a river. A river with lots of rocks has a high resistance to the flow of water. A lot of the kinetic energy of the water is transferred into sound energy. In an electrical circuit, the resistance is how hard it is for the electrons to flow. The resistance is due to ions in the circuit, like rocks in the river. The ions are the part of the atoms that do not flow, unlike the electrons. A lot of the electrical energy is transferred into heat energy. So we're going to look at electrical energy now. The electrons do not carry energy from the battery to a bulb. The battery creates a potential difference across the circuit. It does this by creating positively and negatively charged terminals. Creating this potential difference requires chemical energy from the battery. As an electron travels through a bulb, for example, it will do work. This is because it encounters resistance. This resistance produces thermal energy from the electrical energy. The electrons do not gain or lose energy. They simply do work as they pass through. They do work by transferring their kinetic energy, but their energy is replenished as they are pushed around by the potential difference. Light bulbs and fuses, this leads to quite nicely onto. A light bulb contains a very thin wire inside it, so there is a lot of resistance. It is for this reason that light bulbs get very hot and produce light. A fuse works because it contains a very thin wire that melts when it gets too hot. A fuse only lets a certain amount of current through, otherwise it melts. A bulb blows because the wire inside it melts, just like with a fuse. This model is used for the following circuit simulations. Conventional current is said to flow from positive to negative. This was decided long ago before the electron flow was understood. In a series circuit, the current is the same throughout the circuit. This is because the flow of electrons is the same everywhere. The voltage across the bulb is the same across the battery. This is because all the work is done across the bulb. If a circuit is not complete, then a current cannot flow. This is because there is no potential difference across the circuit. In a circuit that has been short-circuited, the bulb will not light. This is because there is an easier way for the electrons to flow. In a series circuit with two batteries, the voltage is doubled across the battery. The voltage therefore doubles across the bulb, as twice as much work is done. Therefore, the bulb shines brighter. You can imagine water flowing down a steeper river. In a series circuit with two bulbs, the voltage is split between the bulbs. This is because the amount of work done across each bulb is less. The amount of work done is the same across both bulbs together. The total voltage across both bulbs is equal to that across the battery. You can imagine a river dropping down two shorter waterfalls. If one of the bulbs blows, the other will not light because the circuit is broken. In a parallel circuit, the voltage is the same across each bulb. This is because the amount of work done by the electrons is the same. The current is split between the two bulbs because it has to travel two paths. You can imagine two streams converging into one river. If one bulb blows, the other will still light because the circuit is still complete. Okay, so we're now going to use this model. The ions are static and the electrons are free to move. The electrons are much smaller than ions. Obviously, this is not to scale. In a circuit, the electrons must flow around stationary ions. The more ions there are, the harder it is for the current to flow. The resistance of a circuit can be increased by using certain materials. It can also be increased by increasing the length of the wire or making the wire thinner. Direct current, or DC, means the current flows in one direction. Alternating current, or AC, means the current alternates direction. Therefore, the direction of the electron flow switches. This explains how electrons simply do work as they pass through the bulb. We can add resistors or bulbs in a series circuit. When we do this, the total resistance of the circuit increases. We simply add the value of the resistors together. The electrons can only travel as fast as they can through the narrowest point. You can imagine this like water in a river when the river changes width. Therefore, the total resistance of the circuit is the resistance combined. We can add resistors or bulbs in parallel too. When we do this, the total resistance of the circuit is less than resistors themselves. We don't simply add the resistors together. The electrons can travel faster when they are all in the same flow or wire. You can imagine this like two streams joining together into one river. Therefore, the total resistance is the sum of 1 over the resistance combined. We can now look at some calculations that relate to what we have looked at. Measuring current. Charge is measured in coulombs. The current is the rate of flow of charge. This means that the current is measured as coulombs per second. This has a special name called the ampere. We thus measure the current in amps. An ammeter is put in series in a circuit to measure the current. Voltage. The work done measures how much energy is transferred in joules. Therefore, the voltage is the amount of joules transferred per coulomb of charge. This has a special name called the volt. We thus measure the voltage in volts. A voltmeter is put in parallel in a circuit to measure the voltage across. This is because it is measuring the potential difference across the circuit, or indeed across a component. Resistance. The resistance of a circuit can be calculated using Ohm's law. This is the voltage divided by the current. This is given a special name called the ohm. The resistance is therefore measured in ohms. Power. The power is the rate of transfer of energy. It is a measure of how quickly energy is transferred. It is therefore the amount of joules per second. So power equals energy over time, and this is equal to power equals current times voltage. Now this is the same thing. I just want to show you here that if we multiply voltage and current together, what we're actually multiplying is the work done over charge multiplied by charge over time. Now these charges cancel each other out. We should divide in charge by itself, which leaves us with the work done over time. Now the work done is just the energy, so we have energy over time. Energy over time is equal to power. So these two equations, power equals energy over time and power equals current times voltage, show that they are exactly the same thing. Power is given a special unit called the watt. The power can be calculated from the energy transferred per second, and the power in a circuit is therefore calculated by multiplying the current and the voltage together. Resistors in series. In a series circuit, the voltage is split between components. The current is the same throughout. The total resistance of the circuit is therefore as follows. It is the sum of the resistors together. So the resistance is equal to the resistor 1 plus resistor 2 plus resistor 3. Resistors in parallel. In a parallel circuit, the voltage is the same across each component. The current is split throughout the circuit, so this results in a different situation. The total resistance of the circuit is 1 over the total resistance, equals 1 over the resistor 1 plus 1 over resistor 2 plus 1 over resistor 3. I've been Mr. Chick. I hope this video has been helpful to you. Thank you for watching.